Curl in the background, little shadow. Just gave a shout out. You guys missed it. All right, let me talk to you about the importance of a rectangular array again. Not to be underplayed. Not to be underplayed. Remember, I was always wanting to challenge some engineers in a Zoom meeting or live chat with my BMA trap, if you will. Now, let's forget that BMA trap. The BMA were to be supported here at this support here, coming all the way across and supported by another BMA here. This was the elevation deck change from the vehicles, above to below. Above to below. Let's just look at the column placement. I want you to think of these are the supports. These are where the cars are. 1, 2, 3, 4, 5, 6, 7, 8. Where the cars go. That's the larger of the columns. And if you look at this as a triangular array, meaning in this case I want you to understand it, it looks balanced. See the distance from here to here, from here to here, from here to here. If you measure, they seem pretty balanced, right? I did that once before in a video, but I wanted to understand the importance of it again. So as I do this, the importance of this little triangle array. I'm going to put them on each one of these little corners. So if you load here, this works out. It's like it's equally distributing the load equally to all 4 columns. Not equally, because this is one section, one length is longer than the width. But that one also. And as we get over here, it's just a clusterfuck. All right. Let's go back to this one. See, that one's just about matched up. This is an 8-inch offset. See the 8? So not quite, but 8 inches is with tolerances per ACI standards. Where's the one that's out here? Doesn't exist. The closest one is over here. Using the offset method, I'm at 13 degrees using from this triangulation, from this area here. This one's 14.6 degrees from here. 50 degrees if I do it where it's supposed to be, which is here, and that's a 50 degree offset. These are just all over the place with offsets once you get out to the parking deck. If this had the BMA going across, let's put it here, and let's elongate this one, and let's see, it goes out to here. Ooh. Brain's working. Car stops, it goes out to here, and then a BMA goes across. So this would all have been parking garage with these BMAs. So now we look at what's left. This would be a step down here. This is where you walk around by the planter boxes and go into the building here. This would be all pool deck area. And then if you look at the rectangular array down here, often I call it triangle array because I start shaping it and then I come up with that statement. None of these are squared up, are they? They're all torqued. They're all skewed. In fact, this one says it's 9 foot 6 inches offset. 9 foot 6 to this one. Clearly written down. It is nothing that was ever going to pick it up. No BMA was ever going to pick this up. I have this as a 20 degree offset from here. From here to here is another 20 degrees, I believe. It's about parallel. This one's 13 degrees. There's just no two-way slab action going on here. I'm going to do this. So I'm going to go like this and bring this over. And I'm doing this because I'm saying that there's a column head there. Let me move this out of the way. And there's your column head down here. There's no column head here or here. Let's back it up. None. There's going to be none. So our grab is here. See it? So now we've got this slab on 3 points. If you just lose it as a panel. 1, 2, 3. You're like, okay, well, it captures over here. Well, that's got its own issues. I shift it over. It's also back there, but this one's sort of middle span, and now we come up with this triangle array that I talked about. I didn't make a mistake when I said I'm having a little fun trying to help you see it. Observe it. It's no rectangling going in here. And now I've come up to here. It starts capturing back to triangle array. This is that pool deck area. This is where the construction joint is also, so, you know, kind of all bets are off there. It allows for that perforation, the removal, the stopping of the deck failure. It comes right there at the joint. There's a 6-inch offset. All right, look at the different. Let's just put it here then. Oh, well, this is longer on this side. Okay, so we go there. Oh, this one's over here. Let's push it down. So 1, 2, we get a nice approximately 90 degree. There's a 6. Where's the one over here? Now I line it up. No, it's still off. It's still torqued. If I could grab this, you would see how torqued it is, and the difference is right here. That little blue line, that wedge, that pie shape. Well, the reinforcement doesn't go that direction. They're not running reinforcement on a skew. They're running at 90 degrees. This is 90 degrees to each other, perpendicular to each other. You can run rebar on a skew to try to capture this. This was not done here. Coming over to this one, we get this one. Oh, it looks like it pretty much works here. So this one is sort of working, except for it now has to do the work of the one that's behind it. This one. Because there is no column there. There's a 6 foot offset here and over. So what's picking up this area here? What's picking up this area? Well, they're trying to share. This one's oblong. See the shape of it? This lighter blue I have here. So it looks like, ooh. Let's see if I can do it this way. Okay, so this is a lot more difficult. Okay, I can do this. Great. That's a loss. So I can do this. Let's change that color because I can. Let's do that. All right, let's bring this one over. So what's picking up this wedge here? This little wedge shape. These are just a box. It's nothing there. Well, there's vehicle loading there. There's planter box loading there. But what's picking up this detail here? What's picking it up? Well, nothing's picking it up. I'm sorry. It's being distributed by the reinforcement around it, but it's not. It's out of bounds for the allowable percentages. Two-way slab failure in design greater than 10% right here, and not more than 20% total combined in rectangular array. So the question is this entire panel a rectangular array up to the construction joint? I would argue yes, because it failed as pretty much one. Now let me give you your fractures. Let's just add the fractures we kind of know. This is over here, fracture. Okay, so can I use that color? Yeah. We have the right here we have the core sample over, let's see, this is KLM core sample. That's showing the fracture of the deck. And now, fast forwarding, which was real, that here is I believe the fracture is going towards here, towards our butterfly. Our butterfly is approximately down the middle of this car. Okay, so down here. This is approximately where the deck folds over like that. Now, butterfly roofs. See, the butterfly roofs were back in the 50s, and they the gutters were down here. This act as a gutter, and you put, frankly, you couldn't do it in any snow places, but it was a unique design, and this reminds me of that. So I coined butterfly punchings here. So our columns here have the rebar. We have that rebar standing at here. 1, 2. 1, 2. This should be number 3. Yeah, I'm out here with that one. And number 3, these pieces of rebar are bent over. So that's change colors. Let's go with red. They're bent over. And red. And let's go red there too. And will it do that? Yeah. So they're bent over in, well, it's sort of like this compass, this direction. So we can do that. Whoops. Spin that around. And it's on top of the column. But it came from here, approximately right there, is where it lost its engagement. 1, 2, and we'll do this one. And there over the column. It's anchored back to the right. So our anchor is here because this is where it stayed intact. So I'll have to move the circle over. Our anchors are here. And this is where it stayed intact. And gave, this is our failure zone. Our failed section is down here. So this is our failed section. And can I do that differently? Failed section, and then we look at what's there, and then failed here. Failed section. So what's there? We have car loading there. And then we have this one here where the Miami Herald released the imagery of the planter box, which is right forward of the column, maybe here, right about here. And its rotation indicator is that it puts just in this butterfly area, that this sagging here would create here, and this would be upon this whole plane, would create the sagging here, would create the rotation here on this box. Let's take a look at that in just a moment. So why do I have that one up? Okay, I'm trying to get to it. And oh, it's overlaying. I know what's going on. So in the background, let's just move that there. In the background, this is the Miami Herald's release. The boxes are not mine. These, like a zoom in is what they did here. So here's the what they're zooming in here, and you can see that this is dipping down. So I'll give her some rotation back here or behind here. If we look at the material, the displaced blockwork, the rotation is down and away, and it's where the gates are, which is the mid span. The gates are about mid span of this column and this column, which puts us here. So we get our deflection on our deck. Why do we get it there? Well, how can we get it there? I did a video stating, even though the fractures here, I did a video saying this appears to be our number one overloaded column. This one here, I chose that one. This is where I said the deflection would show the stressed. But I called this one overloaded and I called this one stressed. Because it has a bigger, larger, when I did all this zoning for this, so I did like halfway between here and here is what I did. The back wall being equal across all of these, save this is 8 inches. So I didn't count that. I just went up halfway between this one over here. And then I pretend like a support was there, and I closed it off here. So I went, delete that. So it went like this. So my initial one was like this, and let's change that. So it was like that. And I said, okay, well that doesn't work because this is further out. But this will be a zone. So I said, okay, so this is kind of weird. I got to figure this out. What's the box there? And I made another box for it. And this box doesn't work. See, this is when I do a box from here to here. Well, it doesn't work. Here's this back support, and there's that degree, 5.18. So it really boxes out to here. Remember, this rebar is not on a skew. It's 90 degrees, so I'm trying to work with that. And then here it goes here. So I'm like, okay, this still doesn't work. So then I have to use just odd shapes to try to figure out its mid-span. So I break it into chunks now. Okay, I say, okay, well that's there, but there is no half from here to there. There is no other half. It goes clear up to here. Let's get rid of that now that you can see it. Let's move this out of the way. It's just airballs. Remember the reinforcement. This reinforcement is straight. All right, so what's capturing this reinforcement? Where is it landing on a critical shear zone, a capital, a punching shear protection going through here? It is not. It's just an airball. All right, so how does it get intercepted then? I call it intercepted. Well, there is a column here and there's a column here. All right, so I looked in the reinforcement into this one. the reinforcement in this was just the same. There's no extra reinforcement added. So let's do, can I try orange? So there is no extra reinforcement added here. This is okay. We're going to act like a BMA across here. We're going to add extra reinforcement. Nope. It's got to support itself, and then this comes flying through, and it's got to support it again. All right, so I said, okay, wait a minute. Here's one over here then. Here is, let's do that. Let's just drag that down. Let's multi-purpose it. So there's that one. Let's turn this from red. So now multi-purpose it. Okay, here's a column. Here's a column. All right, so this reinforcement goes across. It crosses this maybe 1.5 pieces of rebar going across this head. All right, so it's something, and it's somewhere close to the critical shear zone. I'm like, maybe it gets 2 pieces, but it's still a hell of a span from here all the way to there. Remember, this is also just on the span itself. It's closer, as I move it over, it's closer to the critical shear zone of this, which would be more rigidity. But if I split the difference and go to the middle from this one to this one, and I follow it up, I'm out of the zone on this one. I looked into them. I'm out. Say this is the critical shear zone. If it was really matted, built that way, which I think it was not. I think it was not. So this is still out of the zone, but this would be a little bit stiffer gradation, and then this would have a critical shear zone also, right? But this is actually, wait for it, this is almost in the plane at the building where it would have been a BMA. And lo and behold, this is a step down. Let's see if I got that right. Yeah, that's the one is catty corner to this one. No, the BMA's over here. The 6-inch step back. Oh, that's what I talk about in another video too. I don't know if you guys saw it or not. That this is a 6-inch setback, and this is that one where they did the core sample. This is also where the floor transition or drop slab detail is. So this one apparently, let me do exaggeration, is skewed. See the 6 inches? It's skewed, or is it? So I say, or is it? It's 6 inches. It's skewed. But I want you to take note of the direction. This one is turned in that capacity, and this one is turned in that capacity. So you're going to get a little bit more different. Maybe you'll get more rebar on it or not. All right, so I'm going to drop that down a bit to show you the skew, 6 inches. So coming back here, we put they don't exist. But if they were there, and this was the cowl, and this was the reinforcement going by, it would miss it. But over here, it wouldn't miss it. It would grab it. And it's sort of like a strong shoulder now. It would be able to reach and grab some of it to the right of it to stiffen it up, and same thing here, some to the left of it, and then the rest would just be tributary area. But these don't exist. The way this failed without the leaving behind what I call the capital, even though it's not a capital, it's where the critical shear area is built up. When it strips down, if it's built up correctly, you'll leave a square, if you will, the shape of the critical shear zone, which I refer to as like my butterfly thing. I've called that like the capital. No, it's not technically a capital, but it presents as a capital when it's left behind, is what I'm driving at. So that shows me that it was not there. I find that whenever they're left behind, the critical shear zone was built up. It creates a rigidity, a gradation, when you have these critical shear zones like this. And in between those two are the tributary. I've gone over this for you before, showing you a chair. And George was on the chair, the cat. So this is the tributary zone between these two. By default, its rigidity is above the column, a lot more rigid than right even out here. But as you go to the middle, that's its least rigid point. And then your gradation and going back up, theoretically, if everything's balanced out. That you're not doing something like this, stressing it too far. So if you were to put now, I know this is a complicated video, but I think you guys can follow. If it had a critical shear zone here, and there was one here, if, that's an if, it was not, because we see what's left, there's like 2 pieces of rebar. And let's get rid of that. Those are the anchors that failed, if you remember. Yeah. Those are the anchors that fail. If these were critical shear zones, and I could draw them in for you now, and draw them in, you now start seeing the tributary zone around them. And hopefully as I do this, you now see how chock-a-block the behavior of this deck would be without having symmetrical loading. This was all a skewed loaded deck. Now this is if they were there. These aren't there. They're not there. Use your eyes and glean over this, and you can see how my lines match up, and how this is, maybe this one would be nice. These would be nice. This is stepped down, but the back wall here would pick it up a lot. So just looking at this area here, this is our butterfly area where we go down, where we see the valley, if you will, of the collapsed area. You can see why. These are great distances, and they're skewed. They're not opposing each other. They're not opposite each other. They are in here, and this is where we get our shear break, right about at the wall. Right here is our shear break. This is what I showed you the other day. You can see if you look at the collapsed car, you start to see a little piece of this column right there at the top there in the corner. I showed that to you in the other video. And that's what you see, the top of that. This is because, let's get rid of this one. You can see that they're in line. And so, where is it likely to crack? Well, we have a crack here. We have a bad core sample here and over here. The loading is more excessive over here. Now, the core sample, I explain that via, well, it's very soft concrete, right? It's very inferior concrete. I have that from one of the contractors over there. I do not want to give away more details than that, but they verified that that this was a joke of a pad to secure to. Not the top part, the underside. All right. Again, I don't want to give away the contractor. Unless he gives himself away on this. But so now you're seeing all this skewed behavior. But right here is where you see the butterfly. Can I get a different color, one that works better than that? It's not contrasty enough. Okay, so right there is where we see our butterfly, right here. This is not there, it's just a box to show you that how this should work. See how it doesn't work? It's just everything's out of bounds over here. It just doesn't work. I'm going to come over there. I have to make it narrower now. It just, that's the crack, the existing crack. It just doesn't work anywhere, does it? It's all coming up short. It's all coming up short. And for a two-way slab. Now they said this is a two-way slab system, and I would argue that it doesn't meet any criteria for a two-way slab system. And now let's talk about the you know, over here, right here, this section does, but because it all acts as one, the combination in a rectangular array, question here in ACI 1980-79, per the code there, I have the code book for that. So I'm quoting that code, and it's still today. The train of thought, train just left the station. Going back here, our triangular array. Okay, our spans are, it's going to come to me. I'm not there yet. So you can see that the spans are greater here between these two, and they're skewed. So the steel is not, I have what I'm going to say now. So the steel is not, it's 90 degrees, so the steel is just missing here. The steel is just bypassing all of this. There's no BMA picking it up to make that transition down. So this top steel is number 5, and the lower steel in this deck is number 4. So it's equivalent, as I stated, upside beam. There's a 5, and there's the 4. So as this deck deflects, the 5 wants to act as a strong back. It wants to change the whole behavior of that. I researched that many years ago on a beam where they changed the steel like that, and it was not good. You don't put the larger steel at the top. You didn't get the you didn't come out on the positive side on that. So this is what they have. They have a stronger piece of steel, if you will, at the top, and a more flexible steel at the bottom, more rigid steel at the top. So you can imagine when the deck deflects, you can get separation of the steels. Oh, wait a minute. We have that in the core samples, don't we? Here and here. As you get deflection, as you get this temperature steel for the controlling of the sun expansion. So the issue, though, is they don't have any control besides the control joint here. They don't have any expansion joints around the deck. It's just they locked it in, and yet they're talking about expansion problems. But they're saying we're going to confine it all with the steel, with the grip force of the top layer of the steel. The grip force will hold it together where it will not be able to elongate. Well, 1980s they had all these repairs they did in this pool deck and the parking deck with urethane. Initially, they changed it to epoxy. This thing was just doomed. All right, so I just want you to see this. Okay, so this is so you can see it better, but remember these don't exist. So if I remove these, you're just going to look at the steel that just happens to intersect. So you could do this. You could make like these mini boxes, and each size of the mini box would literally, not figuratively, be the size of each column. Reason why I say that I believe I can get away with saying that, is we see the deck punching shear just left only the columns, and this is what I tried to describe to Professor Lehman, that how punching shear, how you can quickly observe what kind of punching shear you're looking at, whether it had critical shear zones, which is critical to understand, that a critical shear zone and tributary areas. It's critical to understand that. Most of this deck was just tributary area over to the only critical shear zone was literally just the column head. It was limited to that. And then that's shown when your deck fails, you get nothing like a capital left. It's just the heads, just a column, like it's stripped off. Now and that's the way it does it. Now, not to underplay the overlay that was put on top of this deck, that had a weird sense of ability to hold, to give buy time for the deck over here. As it, let me just take a little sample for you. I'm going to try to do this. I'm going to put this, let's just pick on this one column here. Now let's put this large pad on top of there. It's under there, see it? So let's put this pad there. The pad has this slab that was added. I forget the dimensions, it's over here somewhere. It had an ability to bridge over top of the column heads and act as its own critical shear zone. And then let's do another one here. And then here's the other one. And then it had its own tributary area that would have been assisting on deflecting the deck. So let's put that one there, and then let's put one here, the slab itself. Now you see that where it's loading now, so some of it by default will transfer its load, because by default it's over top of a column also, and it has a rigidity to it. And the reason why I make it kind of large like that, because at the pool over here where there's column, I believe it's that one actually, we see the slab like it misses the column a bit, or it goes over top of it, and it's something like that. It's, well, here's a measurement. It's about 9 feet that it can cantilever, that it can be rigid. So I'm like, oh, that's pretty friggin' impressive. You know, this is not just a layer that didn't have ability to perform. It was pretty tough. So let's do that. So 9 feet would only give us, what, 4.5 feet around each column. Or you can try to say, because that was ledge too, so it's a little bit of behavior. So maybe we'll go down to like 5 feet. All right, so something like that. So then we drop this one down to about the same, thereabouts, about 5 feet. So here's your tributary area now. Now, it was not a composite deck. That means it wasn't anchored to the deck below. and they didn't, get a strong back and get a different behavior action, larger dimensions and everything. It didn't do that. They didn't anchor it to the below. They had a great opportunity there to do that. It was not done, and that was that engineer Long, I think Long Tong TONQE, something like that, or GUE, something like that. So there's our tributary area now. This being different. And so it still has to, when it tries to deflect, it still has to pull on the entire, its own slab also. Remember Cassandra Bilodeau Stratton, pronunciation my fault on the first name. She observed what she said was a sinkhole. She didn't say the building's the deck collapsed back to here. Her visual probably would not include the car. She did not mention that to her husband. I did talk to the mother. I do know some more details, but it's not able to share. So you guys will have to do some extrapolations. And so the pool, so she observes what she believes is a sinkhole. All right, and that puts it in line with this, with the butterfly collapsed area. Remember though, this area has it can't support itself. There's no cars there, so she's probably watching something like this. We'll see, is that the KLM? Like this is probably what she observes. And then the photographer films here ultimately. Whoops, backing up. And it's behind one more. Maybe one more. That's the column that everybody's questioning. I believe it's that one. So the sinkhole is just a depression in her view, in her eyes, because she's up 4th floor, I believe it is. So 40 feet up, 30 feet up, let's call it. And so don't throw away the top layer as not having something to do with this. Now we have this top layer like that. It's over top of each one of these heads doing that. But over here at the column here, it can't, see over here is the pool deck. It can go over top of it. But over here, it just goes up to it. See, the slab just goes up to the column. It butts to there. No anchoring, no dowels, nothing. So it becomes a dead load here. DL. Let's put DL. Oh, I can't. Huh? DL. So this is a DL. That's DE, I guess. So this becomes a dead load over here where it wraps around the column. It can't go over top of. And neither can it go over top of this one. There's the car parking area. Or this one, or this one. Over here, it does. Where the parking cars, would it park the car? Not further. Oh, yeah, it's back ball. No, so none of these, yeah, I'm trying to get my bearings. None of these, but this one's outside. This is a small one. All I got to find the small one. The small one, it's over top of. This one is a large one, so it goes up to the building. So it's like this. It butts to it. And when it butts to it, let's see if I can do another one. This is now just a dead load and a stress. Excuse me, in a shear capacity. A dead load from here to here. It's just placed on top of the slab, stressing this. Now it might have some rigidity though, as the car goes over. It's like laying an extra piece of plywood on top of the plywood. It gives you rigidity. They don't bond together, but the multiple layers, they do add something to it. Anyone that's worked on scaffolding knows that. 1 2x12, as you might walk on now that's illegal. You got to use OSHA-approved boards. But a 2x12, if you lay another 2x12 on top of it, without even securing them together, without screwing them together, you'll get less deflection than if you just had. You'll get less deflection by just laying it on top. So when I say, so engineers out there might say, well, no, it's got to be screwed or it's not composite. I simply prove to you that, I simply offer for proof to you that, think of scaffolding. I know most engineers don't go on scaffolding, but just think of that. Another 2 2x12s on top of each other, you'll get less deflection. All right, it does help. it does have its own composite ability. So this layer does help, except for it increases shear around the wall there, because there is no extra securement there. It is just a dead load there. You get the vehicles over there, you get even more dead load. All right, I'm going to end this video. That phone call came through anyway. So this is, think of the extra layer as an extra layer of two 2x12s on top of each other on scaffolding planks. That don't discount this top layer for giving a long life cycle. Don't forget that this skewed. The column didn't change position when they removed the BMAs. When this BMA was supposed to go here, was it here? And then deleting. And then, shoot. Oh, it moves over a bit. Here. And then from, yeah, great. I've got to get this phone call. And then this one was supposed to tie in there. And this is where the pool was supposed to, the parking was supposed to stop. But they changed the elevation, making it all one, and that made this hell to come. And it became due. All right, I know this was kind of a long video. Again, I want you to think of that top layer as two layers of 2x12 material stacked on top of each other. They may not be secured, but they still have a composite and ability to resist deflection. But over here, because they're over top of the heads, that's great because they create their own little critical shear zone areas by default being over the columns. Over here, they're not over the columns; they're butting up to. So now they create, still get your plywood effect, but now it's equivalent to having your layers, your extra layer 2x material, butted all the way up to the edge of the scaffolding, but not actually over the pipes. So it comes up short, and it creates a larger shear stress on that deck here and here, and that one's covered. Oh, the planter box. So the planter box had been butted up to the planter box. They didn't remove it and put this down, as I understand. So the planter box had been different. Although I have a video that shows kind of weird. The planter box is not there at all at one point. And I never shared that with you. I'm just like, yeah, I don't know where that came from. I'm like, you know, it's weird. Makes me wonder if they redid the planter boxes totally. Let me remove some of this stuff. All right, so what I want to get there. That's it. Just wanted to, absorb that. Let's go from there. Love you guys. Of course, I got more. This is just stack layering for you. Don't forget the 5 and the 4. Don't forget the wiring. Forget it. Bye. Love you. Bye.